So with that being said, let's go ahead and look at who is Studica. So among a lot of different things, Studica is also a robotics manufacturer and distributor for education. And we're a global partner with World Skills International, otherwise known as WSI, particularly for the mobile robotics competition. So World Skills Robotics, or WSR as it's sometimes known. And what I'm going to be talking about today is the sensor and motor training kit that we developed. And part of the reason we developed this is because we saw a need for a product that teaches robotics and controls using LabVIEW and the MyRio data device. So this program that we're going to be looking at today is suitable for higher education as well as robotics competition teams that look to use LabVIEW. So this is often found in the realm of WSR, WRO, and FIRST Robotics. So our product is looking to train in the use of sensors, motors, and actuators. And the full name of the product, which is a bit of a mouthful, is WSR Sensor and Motor Training Bundle for MyRio and LabVIEW. So this is kind of a picture of the sensor kit. Sorry, I'm getting tongue-tied here. This is one part of the kit. The other part is a motor kit, which we'll look at a little bit later, but we have a MyRio device connected to the sensor board here, and you can see that there's quite a number of different sensors we can be working with on this device. And again, to kind of reiterate, we saw a need for some kind of tool that taught both LabVIEW as well as control sensors, motors, and actuators, and we feel that this sort of fits that niche. So first we're going to look at the sensor board, but before I hop into that, we're going to talk about what comes in the kit. So we have both a sensor and a motor board. So if you get the kit, you'll end up pretty much getting what you see here. The sensor board here on the bottom left, and then the motor board's over here underneath the the power cable. And it also includes courseware with exercises, and we'll discuss more about the courseware a little later on. But basically the courseware seeks to really get you up to speed with the hardware and really working with, controls, motors, and sensors with this board. So there are two different bundles. One bundle includes the MyRio and the LabVIEW, and the other bundle does not. So it's important to kind of know this distinction, because if you don't have a MyRio and you don't have LabVIEW, then you don't want to be getting the bundle that does not include either of those things, because these boards do require both of those things to operate. You have to have a MyRio to connect to the boards, and you have to have LabVIEW to program the board. So one note here is that LabVIEW student licenses will not work, because you have to have the MyRio toolkit, and the LabVIEW student edition does not come with the MyRio toolkit. You also need to have the real-time module. So both of those things are not included in the student version of LabVIEW. However, if you have a university site license of LabVIEW, you do have access to those toolkits. So if you have LabVIEW student version, it's not going to work with these boards. If you have the university site license, it will. If you don't have any version of LabVIEW, then you're going to need to get LabVIEW, and we do have a package that includes LabVIEW with the MyRio. So first, let's take a look at what the sensor board is. So you can see the image here. Gives a pretty good look at all the different sensors we can work with. Pretty big list over here. I'll kind of let you read some of that. The big ones to me, or at least some of the ones that are featured pretty heavily in the courseware, like the photoresistor, the thermistor, your toggle switch. You'll do some work with the relay, the IR sensor, the ultrasonic sensor, the 3-color LED. There's also some courses for the passive buzzer, and there's also a inertial measurement unit with a 3-axis gyro, accelerometer, and magnetometer. So it's kind of, basically you're getting a whole lot of different sensors to work with here to be able to experiment, do data acquisition, learn your way around sensors and control solutions. And even if you know your way around it, this is also a good device to have for things like research, or if you're trying to maybe test something, doing like a prototype or anything like that. You have a lot of sensors here to work with. Now the motor board, you have an image here, and you can get a good look at some of the motors on this particular board. Not quite as many bullet points here to go through. So we do have a stepper motor drive circuit, also a hybrid stepper motor, a DC motor drive circuit, a DC speed reduction motor with orthogonal encoder. We also have a pulse width modulation controlled analog servo, a solenoid valve electromagnet drive circuit, and a 7-segment LED digital display tube. So the idea here is to basically give you a number of different types of motors to be able to work with. So again, if you're doing research, if you're learning, if you're prototyping, whatever it is you're doing, you pretty much have access to most of the kind of motors that you're going to be working with. So the idea was to try and put as much as we can here so that you have that flexibility to work with what you want. Now on the topic of the courseware, basically the courseware is serving as an introduction to using sensors, motors, and actuators with LabVIEW and the MyRio. So you start off with a detailed installation instruction for both the MyRio and LabVIEW. So you'll basically, if you've never worked with the MyRio before, it's going to walk you step by step with how do you actually set up the MyRio, how can you configure it on the network, how can you configure it for direct connection, and then how can I actually implement that into a LabVIEW project and start working with it. And then on the LabVIEW side of things, there's incredibly detailed documentation in the courseware. I had to proofread the courseware, and when I was going through it, I've actually never seen a more detailed tutorial for LabVIEW, and I've worked with LabVIEW for a number of years. It goes step by step through the very basics of LabVIEW into advanced techniques with the software. It's really well done, and it's actually a really good resource. Even if you know LabVIEW pretty well, you'll probably actually learn something if you just look through the courseware and the LabVIEW section alone. And then after we kind of give that introduction on how to set up everything, how to use LabVIEW, there's detailed introduction, there's going to be basically like tutorials that you follow along with to work with the board and the MyRio. So you'll do things like setting up a photoresistor and graphing the resistance on the photoresistor, setting up the IR rangefinder. Then you'll go into things like using the motor board, doing, setting up your DC motor and things like that. So the courseware is quite detailed. The step-by-step instructions are very clear, and it really lets you understand how to use these boards, basically what the board schematic's like, and all the different pins, how they connect to the MyRio, and why we care about those, and how we can make them work with these boards to actually execute the functionality that we want. So I'm going to look first at some of the sensor board exercises. What you'll start off doing is looking at how to read data from analog sensors, and then you'll jump into doing digital input-output. Then we'll look at pulse width modulation, and then we'll manipulate the serial port, the I2C bus, the SPI bus, and then we'll do some orthogonal coding. These are kind of the big ones that, at least when I was going through the courseware, these were the big points that were really hit on. But there are some extra lessons as well that I just didn't list here. So the idea is to really get you familiar with all the different features of the board. So with the analog labs, you'll end up, basically I think the first lab in the courseware is a photoresistor experiment because it's very straightforward. The program is actually very simple, and setting that up doesn't take a lot of time, and it's a good way to kind of get your feet wet with the board. So the photoresistor, you're basically going to set up the analog input and output so that you can actually get the photoresistor data to map onto LabVIEW. And then there's another lab that looks at using or graphing distance measurements using the IR rangefinder. And then you'll use a thermistor to graph temperature changes, and then you'll also do a lab with a 2D rocker control like we see here at the bottom right. So to kind of show you what the photoresistor lab ends up looking like, I'm going to go ahead and show that in LabVIEW, and I've got way too many tabs open, so let me browse what I got here. Okay, so I have my LabVIEW project window, and I can open my photoresistor VI, and for people who maybe haven't used LabVIEW, a VI is basically a program. So this is basically my front end is just a waveform chart that's going to show me my photoresistor measurements on a graph over time with an amplitude, which is the resistance of the photoresistor. Then I just have a stop button here. And to show you sort of what the back end looks like, the block diagram, I already have this program built to basically save time. Don't want to keep everybody here too long, so This is what the actual block diagram looks like. And again, if you're not used to LabVIEW, a block diagram is essentially your code. So LabVIEW is a graphical programming language, essentially. So by placing blocks down and making connections to different inputs and outputs, you can create all sorts of behavior. And this interacts with the MyRio board, which then interacts with the sensor board and basically sends signals to the sensor board to like get data. So in here I have a loop, which all of this is contained in. I have an analog input coming in on pin 7, which is where the photoresistor is. And I'm telling it to output to the waveform chart. And then I have this time delay here for 100 milliseconds so that I actually have a little bit of time to read my signal. If I don't have this here, then the signal kind of looks like it's going all over the place because I have no delay between my updates. And then lastly, I have this MyRio reset where if I have any errors, this will basically trickle out from here, hit the MyRio, and then reset the device to like a neutral state. So this is basically the program. It's very simple, but this is like the first thing you do in the courseware, which really gets you to kind of understand how to work with everything. And so if I play this, it's going to send the data to the MyRio. And then once it's done loading, we see that the graph is now showing me basically resistance on the photoresistor, which is, you know, brightness. Like as we have more brightness, the resistance goes down, and if we have more darkness, the resistance goes up. So let me pull up my camera just so you can kind of see here. So I have the boards a little bit out of focus. I can't really fix that, but the photoresistor is right here where I'm pointing my finger. And if I kind of put this side by side, it's, whoops. Okay, sorry, I got so much stuff on my screen. So if I cover the photoresistor, you notice that the resistance in LabVIEW is going up. If I take my hand away, it goes down. If I put it like somewhere a little higher with some shade, you see it going up, and as my hand gets closer, it just keeps going up and up. And again, can't really see there we go, the MyRio. So again, the MyRio is what LabVIEW is talking to, and then it's sending through the connections here, it's sending to pin 7 to tell the photoresistor that it wants data, essentially. So that's pretty much what this setup looks like. And let me hit stop here. Sorry, I forgot to mute my phone. And let me close this slab. Okay, so back to here. That's a general look at the photoresistor lab. And again, that's a very simple lab, very introductory, but that hopefully gives you a little bit of an idea of the workflow involved. And then after the analog labs, you end up going into the digital input-output labs. So you're going to look at working with an LED control, a relay control, a touch switch experiment, and using the toggle switch as well as the rocker button for digital input. So with the rocker button, many of you probably use something like this, whether playing video games or controlling robots with like controllers. There's analog signals that are sent when this is moved left, right, or forward and backwards, but there's a digital input as well when you push in on the button, right? So you get to experiment too with that digital button. We have the toggle switch here, which will, in the courseware, you basically use this to turn on a series of LED lights using some simple like Boolean logic. Then we have the touch switch here, which you touch it with your finger and it turns an LED light on and off, so you'll get to experiment with that. And then we have the relay here. So in the relay lab, you basically look at switching the relay on or off, which can then power some kind of external device that has like a higher voltage than what your board can handle. So those are what the digital I/O labs are like. I don't have a demo for any of these prepared, so this is just to give you an overview. And then from there you move on to pulse width modulation labs. So with the pulse width modulation labs, there's also a lot of information about what is pulse width modulation and what's some of the terminology we care about in pulse width modulation, like frequency and duty cycle and things like that. And then what sort of things do we actually use pulse width modulation for? And so you'll look at doing a 3-color LED experiment where you'll use this image in the center here is the 3-color LED, and you create this front end in LabVIEW like you see in this bottom right image where you can control the RGB value that's being sent to the board, and this utilizes pulse width modulation to basically create a seemingly analog signal over a digital signal, right? So that's kind of the whole idea with pulse width modulation, and then in doing that you can basically create any color you want on this RGB light here. And then you also have a passive buzzer experiment where you create like a series of keys on the LabVIEW front end, and those correspond to different frequencies, so like 440 hertz or like 1200 hertz for instance. And then when you press those keys, it sends that frequency out through pulse width modulation, which basically sends to the buzzer, and the buzzer outputs that frequency. That one was actually one of my favorite ones because you can kind of like make music with it if you plan it the right way. So this is kind of what you'll do with the pulse width modulation labs. And then from there you move on to the I2C labs, where you take a look at what is the I2C bus. You know, why is this useful? What do we use this for? And it also talks some about the different like connections of the I2C bus and what they're each used for. So it actually gets really technical. There's actually a lot of stuff I didn't even know about when I was reading that, and I learned some things about I2C. But in here you'll be doing a 9-axis gyroscope experiment, doing some digital light intensity sensor experiments, and display control button recognition experiments. There's a lot more sensor lab exercises. Those are just some of the big ones I want to point out since we don't have all the time in the world today. So I'm going to move on to some of the motor board exercises. And with the motor board, you're basically going to look at how do you use all the different motors on the board. So you'll look at stepper motor, steering gear motion, DC motor, solenoid valve electromagnet control, and then a digital tube display. So with the stepper motor labs, you'll figure out how to do stepper motor forward and reverse, how to control the rotation speed, how to control the rotation angle, and then doing acceleration deceleration control. Alongside all of this, kind of like with the PWM and I2C labs, you also end up getting kind of like a crash course on what is a stepper motor and how is it different from the other types of motors, and you know what kind of things is it useful for. So you get to learn quite a bit about why this motor is helpful for you and how to use it properly, and you know what sort of areas that you're going to use that motor for. And then you'll also do DC motor labs, where you're going to look at making the DC motor go forward and backwards, or forward and reverse I should say. And then you'll look at controlling the speed in an open loop, doing speed detection using an encoder or a rotary encoder, and then doing control speed in a closed loop, and then detecting motor position in a closed loop, and then kind of like I just said, you end up using an encoder and PWM for this particular lab. So you're actually combining some of the things you've done previously with the sensor lab for this, except now you're also using an encoder to do like loop detection, rotation detection. So, and then again, kind of like with the stepper motor on this particular lab, you're also going to be looking at, you know, what's a DC motor, how do we use it, why do we use it, and all of that. So again, you kind of, with all these labs, one of the common themes is that we're not just showing you a step-by-step tutorial on how to do something. We're also trying to talk about, you know, what this particular technology is and why that's useful and how you make use of that. So you'll find that in pretty much all the different labs that you do. There's going to be some level of introduction about this particular technology, and it can be really insightful. So with this one, I'm also going to do a quick demonstration. However, I need to swap my boards out, so let me bring up my camera just so you can kind of see this process. Where'd my camera go? It's right there. Okay. I have so many tabs. I'm trying to keep everything in line here. So the first thing that I generally do is I want to power everything down, right? So I'm actually going to unplug the MyRio, which is sending power to the sensor board. Power is no longer on, so I'm going to go ahead and remove these the ribbon cables, and then I'm going to move this, and I have my motor board right over here. and then I can put this down. And I'm gonna put these in before I turn the power on to the MyRio. And I also need to get the power running to my motor board. So I need to grab my cable. Okay. So I want to make sure my switch is off. So there's a switch right here. Sets the off position. It's labeled on the board. So I'm going to go ahead and plug that in. And now, before I turn that on, I'm going to plug in the MyRio to power. And then I see my red light show up here. So I have a connection, and then I'm going to hit the on switch here to make sure that power is running to the board. And now I have my stuff is all set up, and I've got cables running everywhere. All right. So then for the demonstration side of it, let's take a look at lab view. And it just yelled at me that my MyRio had been disconnected, which it was. So I'm going to reconnect my MyRio. And then it's going to initialize. And then I have my green light here next to the Mark Rio 2 with my IP address, internal IP address. And then I have my DC motor VI here. So I'm going to double click this. And it's going to load. Okay, so this front end is pretty simple, as you can see. I only have a couple of input fields here for motor direction and motor speed. And I'm going to put these down to 0. And the idea is that I should be able to change motor direction and actually, make the motor go either clockwise or counterclockwise, and then I can change the speed to basically up the RPMs of the motor. So if and then I'm going to show the block diagram real quick. And so this one's a little more complicated. There's a handful of different nodes in here. But we basically have our PWM nodes that are handling duty cycle, which one is handling motor speed, the other is handling motor direction. And then we also send to an encoder, which then basically shows us our rotation count, essentially. And then we have our errors. So each of these MyRio nodes have like an error out. So we connect all the error outs to the subsequent input nodes, to the subsequent MyRio nodes, so that if there is an error at any step of the way, this basically trickles down and forces the MyRio to reset into like a safe state so that you don't get any unpredictable behavior. And that's pretty much the program. So these here are the inputs from the front end. So my motor speed and motor direction are controlling the duty cycle of the PWM pin on the MyRio, which sends to the motor board. And then the encoder is only sending an output to this motor count field here. So I'm going to go ahead and close that, and then let's hit play. And then I'm going to save this and open up my camera again. I gotta make it smaller now. This one's taking a little longer to transfer. Okay, so now it's running. Nothing's currently happening because I don't have the speed or rotation, I don't have the speed up at all. So if I start upping the speed, you'll hear the motor start humming, and you can see down here, let me pull this out a bit, you see that this is the actual motor, and now it's running. From my perspective, that's going counterclockwise, but then I can change the motor direction to a positive one, and it starts going the other way. And I can also, and now my motor speed is actually going opposite because the motor direction's changed. So I can make it go pretty fast. So let's bring this back down to 0. And then I can turn it back off. And then we have our motor count working over here. So you can basically see how all this data is working together through the block diagram, how all of our inputs are affecting the pulse width modulation that's sending to the board here, and then telling the motor to basically spin. So that's a quick example of the DC motor lab. And then your other motor labs will be doing similar things where you have some control for, like, you know, rotations, or if you're using the servo, there's kind of a different logic when using servos versus using a normal motor. So you'll end up doing those labs that end up looking similar to this with some slight differences and getting to experiment with some of these other items. So I'm going to go and close that, and I'm going to power this off and go ahead and get back here. Okay. So at the end of the motor courseware, or the motor section of the courseware, I should say, you'll end up doing a lab that takes all the motors on the board and throws them into one lab. So you end up making this really interesting looking front panel that has a lot of inputs that control, like the stepper motor, the steering engine, the servo, and all these buttons basically cause some different thing to occur on the board. So you kind of get to have some fun with it and kind of bring everything together that you've been learning up to this point into one unified lab. And then additionally, I want to emphasize that there's, you know, only so many labs in the courseware. However, that doesn't mean that's all you can do with the kit. The fact that you have such a wide array of sensors and motors to work with means that really you can use the kit for numerous different projects, things that we probably haven't even thought of. Really, it just depends on, you know, how creative you are and some of the needs that you have for what you're trying to do. And the fact that you're working with LabVIEW means that you can really program almost anything you want on the board. So you have a lot of power here and a lot of flexibility to really make whatever you want to make, which ends up leaving you with a large pool of potential projects. And ultimately making this kit a great tool for research, experimentation, as well as custom training. So with that, that's pretty much the big picture look at this board and the courseware that it comes with. So I'm going to go ahead and say, if you have any questions, please ask them in the chat. I'm not going to unmute everybody just because of audio feedback issues. So if you do have questions, use the chat bubble. It's at the top of your screen, the second item on the left on your Join Me panel, and you can ask us questions. We'll do our best to answer those. Can't guarantee I can answer everything, but I'll try my best. And while I wait for any potential questions, I'm going to go ahead and say that if you need to contact us for any reason, if you need to contact a sales rep for any reason, if you're curious about pricing and things like that, you can contact sales@studica.com. You can also actually see this board on our website, www.studica.com. Just look for the WSR sensor and motor training board on our search engine. You should be able to find it. Additionally, if you'd rather talk to somebody directly, you can call us at 888-561-7521. We're open Monday through Friday, 9 a.m. to 5 p.m. Eastern Standard Time. And lastly, we will be sending up a follow-up email to everybody who attended and everybody who is registered. And that follow-up email will have some extra information as well as a recording of this webinar. So if you need to show this to anybody else, or you want to show this to anybody else, feel free to do so. I think that's it. So I'm not getting any questions. I'll wait here about another 15-20 seconds, see if I get anything. All right. Well, I'm going to go ahead and close it out. So thank you all for attending. Hope you all have a good day and a good rest of the week. Thank you.
You are the